Okay, so welcome everyone. This is 7.1 on trig identities. So we went over the basic what the trig identity or trig functions mean, right? That unit. And we went over 45, 45, 90s and 30, 60, 90s, and then we applied that to graphing, sine, cosine, and tangent, and all the 6 trig functions. And now we're getting into trigonometric identities. Okay, so what we know so far is the reciprocal identities, which are cosecant of x equals 1 over sine of x. Okay, the second one, secant of x equals 1 over cosine of x. The third one, we know cotangent of x equals 1 over tangent of x. And also, if we just switch these places, right? Sine equals 1 over cosine, cosecant equals 1 over secant, and tangent equals 1 over cotangent. Okay, well, we also know, it's not the reciprocal identities, but just another one, is that tangent equals sine over cosine. And we also know that cotangent of x equals cosine over sine. Notice that they are also reciprocal identities, right? Because tangent and cotangent are reciprocal identities. So we're just flipping these two guys, okay? The next part of our trig identities is based off of the Pythagorean theorem. So please, you guys know what the Pythagorean theorem is. Right? So it's based off of this triangle here. Okay, in my first quadrant, in any quadrant actually, just draw a right triangle. This is my x value, this is my y value, and this is my r value. So in terms of a Pythagorean theorem, right, using the Pythagorean theorem, what is the Pythagorean theorem based off of this triangle? Yeah, x squared plus y squared equals r squared, correct? And we are going to get the Pythagorean identities based off of this one formula, okay? Based off of this one equation. And how we're going to do that is we are going to make each one of them, there's 3. There are 3 Pythagorean identities. And we are going to make each one of them x squared, y squared, and r squared equal to 1. Okay, so algebraically, this is an equation, right? X squared plus y squared equals r squared is an equation. How do I make r squared equal to 1? What can I do? I can add, divide, multiply, subtract. Divide it by itself, right? So if I divide r squared by r squared, right? I can make r squared divided by r squared equal to 1, correct? So if x squared over r squared, I want to rewrite it just so that I can have my trig function and square it. I can do that, correct? In terms of the laws of exponents. I can say x squared plus y squared equals x over r and then everything else squared, right? Everything squared. Plus, doing the same thing here, y over r squared. What is x over r in terms of my trig functions? What is x over r in terms of my trig functions? Cosine. So cosine squared x plus, what's y over r? Sine squared x equals 1. This, I'm going to switch it around because usually it looks like this, but both are applicable. Welcome to your first Pythagorean identity. Okay, so the first one we have sine squared x plus cosine squared x equals 1. Okay, my next Pythagorean identity, I'm I'm gonna make x squared equal to 1, and just like what Sam said, I'm gonna divide it by itself. Okay, so if I start dividing x squared by all the other terms, x squared over x squared is 1 plus y over x quantity squared equals r over x quantity squared, right? So take a second to think about what x or y over x is and what r over x is. Okay, we got that? What is y over x in terms of my trig functions? What is y over x? 1 plus y over x is tangent. So 1 over tangent x equals, what is r over x? Takes a second, huh? Well, x is my adjacent side, r is my hypotenuse. So what is hypotenuse over adjacent? Secant. Okay, so that is my second Pythagorean identity. Okay, that's my second one right there. And then my third one, I'm gonna x squared plus y squared equals r squared. The last one I did not do just yet is divide everything by y squared, right? So now I can rewrite this as x over y quantity squared plus 1 equals r over y quantity squared. What is x over y? Cotangent squared x plus 1 equals r over y is cosecant squared x. So therein lies my third Pythagorean identity. Okay? Okay, so here are my three Pythagorean identities, okay, that we are going to need to simplify just expressions. Okay? I'm going to preview this as well. One tip when we're simplifying is whenever you see any trig function squared, any trig function squared, okay, think of Pythagorean identities. Okay, that's my tip number one. Okay, whenever you see a trig function squared, we're going to simplify it using my trig identity. Here are my trig identities. Okay, all right. So that is a trig Pythagorean identities right there. Okay. And now we are going to do some examples. How do I use this? Well, the directions are simple. Okay, it's either simplify or prove, right? And we're gonna do a bunch of these guys. So the more you get it, the more experience you get under your belt, the more times that you use our tips, the better you're gonna get at it. Okay, so here is simplify this statement. Cosine of theta plus tangent of theta times sine of theta. Okay, here, my tip number two, turn everything in terms of sine and cosine. Okay, so you want to turn everything into sine and cosine because using just the reciprocal identities and these two identities here, we can turn everything into sine and cosine, right? Cosecant, secant are reciprocal identities of sine and cosine. Whenever you see a tangent or cotangent, you're going to just turn it into this, right? So we've covered all the bases. Everything can be turned into sine and cosine, right? Okay, so let's do that. So I see a tangent here. I am going to turn tangent of theta into sine theta over cosine theta times sine of theta. Okay, and whenever we can multiply, we're going to multiply. So sine over cosine times sine over 1, that's just multiplying across. That's sine squared theta over cosine theta, right? And then cosine theta is here, right? Here's the third tip, okay? Whenever you're faced with fractions, simplify and get the common denominator, okay? Not the lowest common denominator, just get any common denominator, okay? So if it's cosine plus sine over cosine, this is over 1, correct? So what is my common denominator between 1 and cosine? Between 1 and anything. Whatever that anything is, right? Yeah. So I'm going to divide this. My common denominator is cosine, correct? So here, I have to multiply this out by cosine over cosine because cosine times 1 is cosine, and now I have my common denominator, right? So I'm going to multiply the top by cosine, and cosine times cosine is cosine squared theta plus sine squared theta. Okay? I see a trig function squared. Yeah? Trig function squared, trig function squared. What is cosine squared plus sine squared equal to? 1. So this, I can turn this into 1 over cosine theta. Correct? Now what is 1 over cosine theta? Secant. Yeah. Secant theta. And I can't do anything with that. It's simplified. So that is my answer there. When I simplify this complicated thing, it turns into secant, right? So here the directions say simplify. What I can give you is, hey, prove this. Okay, I just added equals secant theta, and I'm gonna go over the steps on how to approach this, right? But the bulk of it, we did already. Yeah, this is the work that you show me, right? Into getting, hey, look, secant equals secant, so I'm done. Yeah, I proved it. I started off here. Yeah, I made my way through. I simplified it. I thought my way through, and I got secant. Okay, and that's what we're doing in this lesson. That makes sense? Yeah. Okay. So let's try one more, and then we'll be done. Okay. So sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Okay, and think of the tips that we just went through, right? The first one was, hey, look, if I see a something trig function squared, I'm going to think of those 3 Pythagorean identities. We're going to turn everything into sine and cosine. Whenever we have fractions, we are going to combine them into one big fraction, right? Okay, that's what we went through so far. And look, we have 2 fractions, right? So what is the common denominator between these 2 guys? Just the product of those 2 guys, right? So my common denominator here would be cosine of theta times 1 plus sine of theta. Okay? So in this fraction here, right, this first one here, I would have to multiply this by 1 plus sine over 1 plus sine. Correct? Yeah, in order for me to get this denominator. Right? So this would just be sine of theta times 1 plus sine of theta. And I'm going to leave it like that for now. Okay. And then here, I'm going to have to multiply this by cosine of theta over cosine of theta to get this denominator here. Right? So cosine times cosine is cosine squared theta. Okay? My last tip that I have for you today is just use basic algebra. Okay? So I can see this, and I'm just going to use my basic algebra skills to distribute this out. Okay? So I have sine theta plus sine squared theta, because sine times sine is sine squared, plus cosine squared theta over cosine theta times 1 plus sine theta. What do you guys think we should do? Having the tips in the back of your head or on your sheet, on your notes. What can I do? There's no right or wrong to this. There's a wrong path, yes, but then if you use your skills, right, that you know, there's no right or wrong. Yes. I can add, no. You can't add a number here because you're changing the problem itself. This? Yeah, you can. What is this guy? 1, right? We just went over the Pythagorean identities, right? A tip would be, hey, look, I see a trig function squared. I see 2 trig functions squared. Yeah, so let's think about my Pythagorean identities. Let's open our thing to this and see. Oh, sine squared plus cosine squared equals 1. Okay, so if that's 1, let's try and change it up. Sine theta plus 1 over cosine theta times 1 plus sine theta, right? What can I do here? Yeah. The sine plus 1. Yeah, this cancels out with this, right? Because using my basic algebra skills, I know sine plus 1 equals 1 plus sine, right? So then that would just be 1 over cosine of theta. And again, what is 1 over cosine? Secant. Okay? So another, hey, prove this statement could be sine theta over cosine theta plus cosine theta over 1 plus sine theta equals secant theta. We just simplified this part, right? Yeah, we just simplified that part, and we did all of this math to get secant theta. But now I can ask you, hey, show me that this equals this. And that could be a proof thing, right? This, to simplify, would be like a level 1 type of question. This, just adding equals secant, that makes it into like level 3. Does that make sense? Yeah. Okay. And my next video, I'm going to go over more of these examples using more tips, yeah, and outlining how you guys think. Cool? All right. That's it for today. That's it for this lesson. And I'll see you guys shortly on the next one.